AP Biology Science Practice number 5. Using error bars to evaluate results. Error bars are vital tools for visually representing data variability in scientific experiments. We use a scenario for explaining the use of the error bars. A new drug is being tested for its effectiveness in lowering systolic blood pressure. So this will be systolic blood pressure. The unit is millimeter mercury at that time. In patients with hypertension, that means high blood pressure, three groups are going to be involved. The placebo group. Group 2 is the medication, the one type of medication, and the third group is another type of medication. We measure the before and after blood pressure with the placebo, medication 1 and medication 2. Each time we have 20 people as the size of the sample for each independent variable. Before starting the placebo treatment, the blood pressure was 145 plus minus 8. The 8 is the standard error of the mean 2 times, so it gives us 95% confidence that the value for blood pressure will be between plus minus 2 standard error of the mean, and after the placebo it turned out to be 140 plus minus 7. For the group who receives medication 1, the before blood pressure was 150 plus minus 6 millimeter mercury, and after the treatment became 130 plus minus 5. For the third group with medication 2, we have 148 plus minus 5, and after the treatment their blood pressure will be 125 plus minus 4. So question is, which medication is effective lowering the blood pressure? Well, before learning statistics, we just said that with placebo it's 140 and 130 is definitely lower than 140, so this drug is pretty effective lowering the blood pressure for patients, as well as 125. Definitely it's different from 140. Here comes the standard error of the mean to evaluate our results. Let's graph the values for the blood pressure. Okay, we will just disconnect a little bit in here because it will be too high. This will be 120, 130, 140, 150, and this is going to be the dependent variable, the systolic blood pressure. I will not write this out. Put the unit in parentheses. It's super important. You will lose points on AP Biology exam if you would not put units on the graph. And this will be the groups, the independent variable. How about we just start to add the before treatment in here to see that the groups are really not different before we start. Again, the mean is 145. Definitely it's different than 150 and 148, but we will see are they really truly different? We will use again the error bars for it. We know that from the previous video that the error bar was calculated by the standard deviation divided by the size of the group, and we divide these two numbers and we did the square root for that to get the standard error of the mean. So here is before. We will have group 1, group 2, and group 3. Before 145 was that. We use bar graphs for that. And plus number 8 is 153. We'll just have a bar in here. And so I put here 153 for you. And 145 minus 8 is 137. 137 parentheses. And this is the error bar for that group. So that means the true systolic blood pressure for hypertension people in the entire population would fall all around between these two values, and I am 95% confident on that. The second group has 150 as their mean blood pressure, but the standard error of the mean 2 times is number 6, so its value 6, so it's 156. Here is that. Oh, this is 160. So 56 will be a little bit here, and 144 it will be here. 144 and 156. And the third group is 148. Here is the bar graph, and if I add 148 plus 5, it will be 152. And if I subtract 5 from the mean value, it's 143. And this is 3 and 152. So what we see is, because the error bars overlap, you see the overlapping values, here is that, and that is overlapping with the first. That means there's no significant difference between the blood pressure before the experiment among the 3 groups. But after the test, we have the placebo group, the first medication and the third medication, and let's see what we will have. First, the placebo is going to be 140. The error bars is 133 and 147. 147, 133. Medication 1 is 130. And error bar 135 and 125. 135 and 125. And the third one is 125 is the mean value, plus 4 is 129, and 121 is the error bar. Now, the interesting part is, let's see, the placebo would overlap, the error bars for the placebo would overlap with the medication with group 2 who gets medication 1. Yes, here is the overlapping region. This area, this overlaps with here, so it means that medication 1 is not significantly affects the blood pressure of the of patients with hypertension, because the error bar overlaps for the two groups. On the other hand, the error bar does not overlap with group 3 who gets medication too, because this error bar goes here and that goes over there, so the error bars do not overlap. So we can say that group 3 who gets medication too we are confident based on the sample size and the standard deviation of the group that the medication lowers the blood pressure for patients with hypertension compared to the placebo. And the point is that using the error bars, and if they overlap, that means they have no significant difference from each other. But if they do not overlap with each other, the two groups' mean value is significantly different from each other. Thank you for your attention and have a good day.